Hi, welcome to this tutorial on Java Lambda expressions. In this tutorial, we will deep dive into what Lambda expressions are, why they are useful, and how to use them in your Java programs. So we will cover what Lambda expressions are. Next, we will look at what is functional interface, and we will also look at an interview question, and we will explain each topic with examples. So stay tuned till end of this video. Now look at what is Lambda expression. Lambda expression was introduced in Java 8 as one of the most powerful feature. Lambda expressions introduces a functional style processing in Java. It enables you to write your code in a functional style. It allows you to think in a functional style rather than object. It also facilitates to writing a very compact and easy to write code. So Lambda makes you write very easy and compact code. Now let's look at the syntax of the Lambda expressions. Here is the first syntax. So a Lambda expression consists of three parts: the parameter, the arrow function, and the expression, the body. So the parameter, these are the input values that the Lambda expression takes. An arrow separates the parameters from the body of the Lambda expression, and the last part comes the body, that is the expression. This is the code that gets executed when the Lambda expression is invoked. This is another syntax of the Lambda expression when you have a multi-line code block. So braces are optional when you have a single line of body. Let's take our first example of Lambda expressions. Suppose that you're creating a social networking application and you want to create a feature that enables you to search any person by filter criteria, like person's first name, or maybe the last name, or age or gender, or maybe a combination of these, maybe the city they belongs to. So just like Facebook enables you to search any person. Let's dive into the code. Let's create the package called person search feature. New package and person search feature, and you can right click and create a new class called person. Now this is the entity class, and we can create the properties. Let's say it has first name, private string, first name. Now let's create the last name. A person can have city, it can have age. Let's take gender too, of type enum. Let's create the gender enum, public enum gender. It can have, let's have just two value. All right. Now we need to create getters and setters. Getters and setters. We also need a constructor and a toString method to print it on the console. Let's quickly create that. Generate getters and setters, select all. Okay, now our getters and setters are done. Let's create the constructor, right click, generate constructor, select all, and okay. Finally, let's create the toString method. Generate toString. Here we go. We're all done with the person class. Now let's suppose the members of the social media application, the persons, are stored in a list, an array list. Real world scenario, it could be a database, but for simplicity we are using array list to store the list of persons. Let's create another class called person star. New Java class person star. Now we can have a method called public static list of person get all persons, and we can return a list of persons. So we are trying to create a mock data to test this out. Person list, new array list, and here we can use the arrays.asList, arrays.asList, and we can create some persons. We can pass the first name as John, let's say the last name is Smith, and city as Delhi. Let's say age is 26 and he's male. Now let's copy paste the other person's objects. So we have total 5 persons class, and finally I need to return this, return person list. Now let's create another class called person search, where we will write the actual logic. New class person search, or we could say, or let's name it as approach 1, person search approach 01. And alright, let's create the main method. Alright, we will create a method which takes one filter criteria. So what I mean, let's see that. Private static void print person by city. Suppose you want to filter the persons by the city. How do you do that? Let's pass the persons list that we have created in person star. So we have again list of persons, that is the return type of the person star find all method. Persons list equals to person star dot get all persons. Now let's print this, all the persons. We will call it all persons. We will print this, print all the persons. We will open a for loop called person p persons list, and then s out p. Let's check this out. Alright, if we are getting all the list, all the persons list. Now let's implement the persons print person by city. So we have to filter this person list by city. So we need to pass this person's list, or we can just call it persons for simplicity. Here we are passing the first argument as persons, and we can pass the city name we are searching for. How we can do that? So this for loop will be needed. This for loop will print all the persons, and we have to put a criteria on the city. So we can create an if condition p dot get city dot equals the city name. That's it, and then only we will pass it. Let's cut from here and put it here. Now this function will print only if this criteria matches, the city criteria matches. This is our criteria on the city. Let's call this and test this out. Let's pass the persons and the city name. Let's suppose Delhi. And alright, let's run this again. Okay, it's working great. We have successfully implemented the filter with the city. This approach is working great, But there is two major problems with this approach. The first approach is this approach is brittle. What it means, your person class have a property called city. What if you want to change this property city with address? Then you have to change this function as well. Another problem is with this approach is you end up creating multiple method if you have to create another filter. Suppose I want to create another filter with city Delhi and age greater than 22. Then I need to copy paste this method and create another method called by city and age, and we will pass the age also int age, and here we will say p dot get age equals age and pass persons city, let's again Delhi and age 22. Okay, I wanted all these greater than 22, sorry. So I need to use this greater operator. Let's run this. Yeah, both the persons have age 22. What if I put 25? I should get only one result. Right, only John Smith. Okay, so let's move on to a better approach where we will pass the filter itself as a method argument. So we don't need to hard code it here. Instead of that, we will pass it as an argument that we will see in the next approach. To understand approach 2, let's create another class. We'll copy paste the previous class and we will name it as approach 2. Now let's delete the second method. We just need one method. We will call it print person conditionally, and here we will pass the instead of city, we will pass a check person tester. I will soon explain what I am writing, and here we will say tester dot test. Alright, so this is an interface with name check person which has a method test. So we are testing. This test person will take an argument as person and it will test the person. Alright, so let's create the check person interface. Right click, new class, check person, and it will have a method called test, boolean test, and it takes a parameter person. Now this is happy because it has a tester interface and it has a test method which takes the person per p and return the result. Now we need to provide the implementation of this interface. So let's do that. Okay, let's remove this examples. So how we can implement the interface? Either we can create a new class and implement the interface, or we can create a local class as well. So for simplicity, let's use the local class. This is out local class approach. Class check person from city implements check person. Sorry, I think I have created check person as in class instead of interface. Sorry. Now from here, we can pass the same condition that we were passed last time. Return p dot get city dot equals Delhi. And let's call the method print persons conditionally and pass persons, and the implementation check person from city and check person from city. So what it will do when it will test here, it will execute this implementation. So let's run it. Alright, the same result, it works. Amazing. But there is a problem with this approach. Can you guess this out? What is the problem? Here also we are kind of hard coding. Even though it's less brittle than the previous one, you can now change the person class, it doesn't matter, because the testing is implemented outside the method. You're passing from outside. Instead of local class, we can use anonymous class. So let's do that. Anonymous class. Now, we don't need to create the local class in case of anonymous class. We will use the same line. Instead of check person from city, check person. And here we go. Just copy the same line. Let's run this again, whether we are getting the same result or not. Right, in both the cases, we have the same result. This approach reduces the amount of code required because you don't have to create a new class for each search and that you want to perform. However, the syntax of the anonymous class is bulky, considering the check person just have only one method. You have to write this many code just to implement this method. That's what Lambda solves the problem, which we will see in the next approach. Now, to move to the next approach, we will create a new class from the existing class. So Control C and Control V, we will call it approach 3 Lambda. Alright, so now let's remove a few things which we don't need. First, the local class approach we don't need. So we are removing till this. And here we have the anonymous class. Now let's look at the Lambda. So Lambda can be used when the interface is a functional interface. So any interface which have only one abstract method is called a functional interface. So instead of all this, let's write the Lambda. So we are passing the parameter p of type person. And we are using the arrow function. This is the syntax of the Lambda expression. And we will say p dot get city dot equals the name Delhi. That's it. You can see how concise this code is. You don't even need to tell the Lambda that what is the type of the person, because it figures out from the check person interface itself. It already knows the parameter will be a p and what is the return type. Also, if just a single line, there is no need of parentheses. So let's run this before. All right. Sorry, we will call it anonymous class, we are still getting the same result. What if I ask you another question? I want to search persons from the city Delhi and age 25. So let's write another lambda. See, we can passing in line, the same line. Let's run this again. All right. Now let's first understand what is functional interface. Then we can move further to improve it even better. Okay, so a functional interface is any interface with one single abstract method. What it means, the interface cannot have more than one abstract methods. And from Java 8, you can also have default methods, and those methods do not count. So default and static methods, we do not count. We are only concerned about the abstract methods. All right, the functional interface provides a target type for Lambda expressions that we have seen in the example before, and the method references too, which we can cover later. There is a new annotation called functional interface annotation, which is useful for compilation type checking, which we will see in this very soon. All right, let's see some examples. Here is your functional interface. We are putting the annotation functional interface. There is a greeting method, and there is just one abstract method. There is no more than one. Let's look at another one. There is no functional interface annotation, but still it's a functional interface. All right, let's look some examples which is not a functional interface. This is the one. Can you guess it why it's not a functional interface? Because it has two abstract methods, right? But it's a valid interface, but not a valid functional interface. This is another example where you're passing the functional interface saying the compiler will start complaining it's not a functional interface. This one will also give you a compilation error because there is no abstract method in this interface. And as I said, as a definition, there should be at least one abstract method and no more than one abstract methods. Okay, right now we are using check person interface. What if I tell you don't even need to create a check person interface? Right, because Java have already created tons of useful functional interfaces for you. Let's check this out in the next approach. So we will copy and create a new class, Lambda, and standard functions. So instead of check person, a functional interface called predicate of type person we can pass. And here we go, it still works. Let's check this out. So all the functional interfaces lies in this package java.util.functions. You can see there is a test method, and we also had the test method. So no need to change the method name here in the if block. So it's gonna still work. If we had a different method name, then we could have to change this method name. All right, let's test this out. So we can get rid of the check person interface now, which is not required. Let's run this. Yeah. Till now, the action of this method is hard-coded here. We are printing this person class. What if we pass this behavior as well as an argument? You don't tell me what to do. I will tell you what to do as an argument. Then it's amazing. We are going to enhance this in the next approach. For that, let's copy paste and create another class. And consumer. Why I'm calling it consumer? Because there is another functional interface called consumer. Consumer of type person, and we are calling it as consumer. And here we are doing consumer dot accept person. So let's check what this consumer interface is. It has an accept method which takes a parameter and returns nothing. It simply executes something and returns nothing. All right. So now our calling method has started failing. So let's start passing those parameters as the implementation of the consumer interface. We don't need this parameter, just pass p and sys out the p. All right. And here let's do a different implementation. Let's say I want to print only first name, right? So for this approach, let's run this here. Amazing. It just printed John. So you could see how easy it is. So whatever you want to do as a consumer, you can pass it here. So you're literally writing API with a very small amount of lines. And this is all happening because of the Lambda. As a last approach, we will use stream with Lambda. So stream API, I will explain you later, but it is also a part of Java 8. So let's enhance it. Instead of writing all this functionality, you don't even need to write any of this function. And stream helps you to work on the collection, on filtering and manipulation. So let's do that. Let's create another class, Control C and Control V, and call it as stream. All right. So here, remove this method. We don't need. Remove this to implement here. So persons dot stream. So this array list have a new method called stream. This was added as an enhancement of collections. So we have a method called filter p dot get city dot equals the. Let's say I want to need only first name. So p dot get first name. Let's for each person, let's print the person. Let's run this. All right, it's working well. Okay, let's take another example of Lambda expression. We are going to create a calculator application where we have two integers. We will build a capability to add two numbers or subtract or any operation on the two integer. For that, let's create a package called calculator. Let's create a class called calculator. Let's create the main method. As you know, every Lambda is backed by a functional interface. So let's create a functional interface. We have an interface called, let's say, int math. And we need the result after the operation on two input integers, a and b, int a and int b. So if we add two numbers, we need the result after the operation. Okay, now it's turn to write Lambda to add two numbers. How we can do that? Let's create int math add, and let's implement this functional interface using Lambda. Let's pass the two parameters a and b, and we are saying when you get this two number, just add it and return this to the addition of the two number. That's it. Let's execute the Lambda. How we can execute the Lambda? To do that, we need to pass the parameters. Int result is equals to add dot operation. We have 5 and 7. Let's print the result. Sys out 5 plus 7 equals the result. Let's run this. Alright, that's amazing. So on this line, we actually create the Lambda, which is the implementation of int method. And next we call the Lambda by calling add.operation, which is the method inside the interface. Okay, Lambda understands the variable type by context. What it means, it already knows that A is of type int and B is also of type int and the result is also of type int. That's why we are able to get the result in the int. Let's write some more operations. How about subtract? And simply put minus. We call it subtract. How about multiply? You could see how easy it is to create any method in just one line. You're just calling with subtract dot operation and pass the value. That's you're done. You have successfully created the calculator. Congratulations. Instead of calling this Lambda manually by dot operation every time, why don't we create a method? Let's do that. Let's create public static int. Let's call it calculate, and which takes two parameters a and b, and the Lambda implementation, the operation. And what it does, it simply returns op dot operation of the two values we passed, a and b. That's it. Instead of calling here, we will simply call calculate 5, 7, and let's pass add. Or simply, instead of putting in result, let's pass it here. We still get the same result. Now let's copy this and paste it at the end. Control X. Now what is 5 minus 7? It should be, now I'm passing subtract. It should be minus 2. Let's delete one, duplicate one more time. What is 5 into 7 is 35. Let's put the multiply. So this function is acting like a calculator where you're passing the two values and the operation. Let's run this. Here we go. You have a beautiful calculator API written in just few lines of code. Amazing. So now let's recap. Lambda expressions was introduced in Java 8, and Lambda expressions introduces functional style processing in Java we have seen in the calculator example. It also facilitates writing the compact and easy to read code. How easy it is, it's just a one line of code and you're writing everything. Like, as I said, it's a replacement of anonymous class. Also, we have seen the syntax. Now let's take the interview question. Does Lambda expression enable Java to provide pure functional programming ability? The answer is no. Lambda does not enable functional programming. It allows you to process data in more functional style. Every Lambda is backed by a functional interface, right? So functional interface is the citizen of object-oriented programming. Java is an ops language where the first citizens are objects, not functions. Therefore, even when you declare a Lambda expression, you must assign it to some functional interface, which is an object-oriented class type. That's an amazing and most frequently asked interview questions. So not only this, so most of the interview questions are: what is Lambda expression? What is functional interface? Does Lambda expression provides pure functional programming? These are the three very most frequently asked interview questions that we have already covered with the example. Now let's again recap the functional interface. As I said, a functional interface is an interface with single abstract method. Default and static methods do not count, no more, no less, right? Functional interface provide the target type for Lambda expressions and method references. So we have covered what is Lambda expression, what is functional interfaces. So in conclusion, Lambda expressions are a powerful feature in Java that will greatly improve the readability and efficiency of your code. Thanks for watching this tutorial. And if you find it helpful, don't forget to like and subscribe. Thank you. Happy coding.